In this lesson, we're going to factor the difference of squares. X squared minus 25 is the difference between two perfect squares. X squared is a perfect square for x, and 25 is a perfect square for 5. The difference of two squares will factor to two binomials, and their only difference is going to be their sign. One will be positive, one will be negative. The first term inside these binomials will be the x, because x squared is a perfect square for x. The second term in the binomials will be the 5, because 25 is a perfect square for 5. Always check your work by foiling, and here we would see the outside and inside terms are additive inverses and add up to 0, which is why difference of squares only has two terms. Next example is 9x squared minus 16. 9x squared is a perfect square for 3x. 16 is a perfect square for 4. So this will factor to the two binomials, a sum and a difference. The first term will be 3x in the binomials, and the second term in the binomials will be the 4. Next example is x squared minus 1/4. Now this looks a little bit different, but don't be alarmed because there's a fraction. Fractions can be perfect squares. X squared, again, is a perfect square for x. 1/4 is a perfect square for 1/2. So this will factor to two binomials, sum and a difference. First term is x. Second term is 1/2. Next example, 50x squared minus 2. Now 50 is not a perfect square and neither is the 2, but you can factor out a greatest common factor of 2, and you're left with 25x squared minus 1. So we do now have the difference of two squares in the parentheses. So this will factor. We see 25x squared is a perfect square for 5x. 1 is a perfect square for 1. So this will factor to the two binomials, sum and a difference. 5x will be the first term in the binomials. 1 will be the second term in the binomials. And then you don't want to forget that 2 that you factored out at the very beginning. Last example will be 16x to the 4th minus 81. Now this problem is a little different because we have x to the 4th, but it's still a perfect square because 16x to the 4th is a perfect square for 4x squared. 81 is a perfect square for 9. So this will factor to two binomials. One is addition, one is subtraction. The first term inside the binomials will be the 4x squared. The second term inside the binomials will be the 9. Now we're not quite done here because 4x squared plus 9 is a perfect square, is not a perfect square, it's a sum. That does not factor any further, but 4x squared minus 9 can still be factored. That is a difference of two perfect squares. So we're left here with 4x squared plus 9. This is the sum of perfect squares, which does not factor. But 4x squared minus 9 does factor to a sum and a difference. 4x squared is a perfect square for 2x, and then 9 is a perfect square for 3. So now it's been factored completely.